Hey there, and welcome to today's explainer. Go ahead and pull up a chair, get comfortable. Look, I know if you've ever opened a math textbook and immediately felt that heavy wave of anxiety hit you, just take a deep breath. It is going to be okay. The math we're exploring today, it's literally something you already use every single day. Think about when you're filtering a website for a shopping discount, or categorizing your phone data, or even looking at how a building is designed or measuring land. Today, we're demystifying a super foundational concept called sets. Think of me as your personal patient tutor. We're going to take this step by step. We'll look at the visual patterns first and uncover the logic together. Sound good? Let's get into it.
Let's kick things off right here with a really simple human question, straight from our source text. When you're asked to describe a person, how exactly would you do it? Really, think about that for a second. You probably don't just rattle off random facts, right? You naturally group things. You might mention their profession, their hobbies, or their nationality. Basically, without even trying, you place them into categories. Okay, let's dive into this and think about how we naturally categorize famous historical figures. Take Ramanujan, for instance. We immediately classify him first as a mathematician, or Dasarathi, who we instantly categorize as a Telugu poet and a freedom fighter. When we think of Albert Einstein, boom, we group him as a physicist. And Maryam Mirzakhani, we recognize her in a highly specific, incredible group, the first woman mathematician to win the Fields Medal. We naturally classify individuals first as a member of a larger recognizable group, and then by their specific traits. See, we categorize things just to make sense of our environment. It's how we process the world. This logic is literally everywhere. Think about it. If you walk into a library, the books aren't just thrown in a chaotic pile in the middle of the floor. They're neatly arranged by subject so you can actually find them. In chemistry, elements are organized into groups so we can study their properties without going crazy. Even your 10th class math syllabus is divided up into 14 chapters under different headings. You are already an absolute expert at recognizing these structured collections. Now, you might be wondering, how deep does this go? Well, what's really interesting is that we can see this grouping behavior quite literally inside our own heads. Take a look at this map of human permanent teeth. Before we even talk about any math, numbers, or formulas, just look at the shapes and the structure. Biology uses the exact same grouping logic that mathematics uses. If we observe the set of human teeth, we don't just see a random assortment of bones. No way! The set is highly organized and classified into 4 distinct types based on how they chew and function. We have our incisors, our canines, our premolars, and our molars. We've taken a complex physical reality and naturally organized it into clean, meaningful categories. And because these physical objects are so perfectly categorized, we can easily map them onto an abstract sequence. The formula for this teeth set is called the dental formula, and it goes like this: 2, 1, 2, 3. That means 2 incisors, 1 canine, 2 premolars, and 3 molars per quadrant. Pretty cool, right? You see what we did there? We just turned biological shapes into a neat, structured sequence of numbers. And that brings us to the absolute core of our explainer today. Mathematics is really no different from the biology we just looked at. Just like organizing a library, or categorizing chemistry elements, or sorting human teeth, math absolutely needs to place elements into meaningful groups. If you can understand the dental formula, trust me, you can perfectly understand mathematical groupings. So let's look at a few examples of the number groups we commonly use in math. Think of these as different families of numbers. First up, we have n for the collection of natural numbers. You know, the standard counting numbers like 1, 2, 3. Add a 0 into the mix and you get w, the collection of whole numbers. Then z represents our integers, which brings in our negative numbers. Now look really closely at q, the collection of rational numbers. These are numbers that can be written in a fraction form, p over q, where p and q are integers, and this is key, q is not equal to 0. That's a very specific property, isn't it? Finally, r is the collection of real numbers which have decimal expansions. See? Math is just putting numbers into their correct, well-defined families. Let's move to our first example and see how this builds into active practice. Let's start super easy, no math required. We need to identify the common property here. What are we given? Thumb, index finger, middle finger, ring finger, little finger. Okay, and what is being asked? The rule that connects them. The solution is super simple. They are the fingers on a human hand. Boom, you just identified the rule for a group. Let's try another quick everyday pattern. What are we given this time? January, February, March, April, and so on. What's asked? Identify the common property. And the answer? They're the months of the year.
See, you intuitively understand the underlying rule binding this collection together.
All right, you're doing great. Now let's step it up to a medium-level, math-specific example. Here is what is given in the problem. 2, 4, 6, 8, and so on. What is asked? Provide the generalized statement that describes this property. Let's look at it step by step. They are all divisible by 2, right? So we solve it. They are all even numbers. You look at the pattern first, and the mathematical rule easily follows. Okay, how about this one? We are given 2, 3, 5, 7, 11. What's asked here? Find what ties these specific numbers together into a meaningful group. Let's look really closely. They don't divide evenly by 2, 3, or 4. Actually, they only have 2 factors, the number 1 and themselves. So our solution? Yep, they are the prime numbers. You are doing fantastic. Identifying that common property is the exact skill you need here.
All right, time to level up. Let's tackle a harder board exam level question from a Think and Discuss section. We are given the collection 1, 4, 9, 16. We are asked to write the generalized statement. Let's break it down step by step together. Well, 1 is 1 squared, 4 is 2 squared, 9 is 3 squared. Exactly. Our solution is, these are the squares of natural numbers. By simply taking a breath and observing the pattern, you've deduced the mathematical rule governing the group. So, after all this natural categorizing, we finally reach the grand reveal, the formal mathematical definition. A set is a well-defined collection of distinct objects. It must be well-defined, meaning the rule is absolutely clear, like months of the year or even numbers. Now listen closely, because here is a pro tip from me to you. The absolute most common mistake students make in exams is forgetting the word distinct. The objects in your set must be unique. We never, ever repeat them. Once we have our set figured out, we need to know how to write it down properly. The objects in a set are simply called elements. To show that these elements belong to a specific set, we write them by enclosing all of them between curly brackets. Think of these curly brackets like a safe little fence, telling us exactly what lives inside our well-defined collection. And this brilliantly illustrates how the notation works in practice. Let's take a mathematical example we solved a minute ago. If we want to write a set of the first 5 prime numbers, we just apply our curly brackets. It is written beautifully as open curly bracket, 2, 3, 5, 7, 11, close curly bracket. The rule is well defined, the elements are totally distinct, and the notation is perfect. But remember, this whole concept isn't just for numbers. Let's go all the way back to the biology of the mouth to prove it. We can write a set of incisors using the exact same mathematical notation. It becomes open curly bracket, central incisor, comma, lateral incisor, close curly bracket. The mathematical language of sets is truly a universal tool for organizing anything that is well-defined. So, as we wrap up this explainer, I promised you a rapid 5-point cheat sheet for your exams. So here we go. Number 1, sets group things by a common rule. 2, the collection must be well-defined. 3, elements must be distinct, never repeat them. 4, use curly brackets to fence them in. And 5, separate your elements with commas. Oh, and here is that surprise exam trick I mentioned. Before you even start writing your set down on the test, scan the question and cross out any repeating words or numbers with your pencil, right there on the paper. It guarantees you won't lose silly points on the distinct rule. Just look at how seamlessly you moved from grouping teeth to defining prime numbers today. If you naturally categorize your environment every single day, aren't you already a master of mathematical sets without even realizing it? Trust your intuition, keep observing those patterns around you, and I'll see you in the next explainer.